Hello there and welcome to this Intelligent Briefing. I'm Jess Abel, Director of Strategic Content at Linchpin Media. In this edition of our Deep Dive series, I'm speaking with Lisa Schwartz, Director of Product Marketing at AEM. She tells us how the enterprise cabling landscape has changed and offers insight into how cabling infrastructure planning will need to adapt to deal with increased numbers of connected devices on networks. Thank you so much for joining me today, Lisa. Could you first of all just introduce yourself and your job role, please?
Good morning. So my name is Lisa Schwartz. I'm the Director of Product Marketing, and I basically handle global presence building activities for AEM.
Thank you. So first up then, can you tell us how the ability to converge multiple building applications on a single communications platform is being realized in some modern structures?
Sure. As we think about this convergence, be it applications or infrastructure components, really the different communications mechanism, the devices that are being connected to the network, this is typically referred to as your smart building or intelligent building, if you will, deployments. And when you think about all of the benefits that this brings organizations, from cost savings, a greener footprint, consolidation and collaboration of the teams that manage the infrastructure. This is thinking about your operational technology teams. These are the folks that manage the HVAC systems, the building systems, security oftentimes. And then we think about the IT, the information technology teams, who are responsible for the security cameras, the Wi-Fi access points, the network connectivity. Historically, these two groups have been very disparate groups. There's no collaboration between them. There's no connection between their technologies. And what this new technology brings is it's bringing these groups and the areas they are responsible for together within a single communications infrastructure. And what's happening is when we think about, let's say your environmental controls, building sensors as an example, that would normally be managed by your operational team as an independent activity and an independent technology, those things are now connected to the network. They're IP addressable. They're sitting on the network. And then, of course, all of your traditional network infrastructure components, your access points, your security cameras, the linkages to your workstations, all of these things are coming into a central network infrastructure and managed centrally. So that is bringing collaboration between your IT and your OT operations teams.
Let's talk challenges then. What challenges are organizations facing as they adopt smart building infrastructure?
Yeah, so there's a lot there, and I'm going to address this from the area that AEM has expertise in, which is that physical infrastructure and assurance that that infrastructure is going to support the needed applications. I think one of the things that we have seen personally with the clients that we work with is these technologies are really still new for a lot of organizations as they're thinking about how they're going to be deployed, what the strategies are going to be to assure the infrastructure during deployment and post-deployment. And so I think one of the biggest challenges is that there isn't quite enough information out there for buildings or for organizations who are going to deploy these smart buildings to have a deep understanding as to what are all of the technologies that I need to put into the specification as this building is installed to be tested. That could be everything from the physical infrastructure itself and how it needs to be tested to post-deployment, and are all of my connected devices functioning as I expect them to function? They need to have some foresight into planning for how that is going to be required to be tested. When we think about testing of the physical infrastructure, historically, there was I'm going to call it basic certification testing that needed to be run according to the ANSI TIA 1152A standard. But if organizations are going to be deploying, all of these different technologies, I mentioned a few of them earlier, but I'll recap, things like your security cameras, access points, security systems. We think about lighting, digital lighting. Believe it or not, window coverings are connected to the network. It's really shocking how many things are actually connected. And in these environments, the testing and the certification of the physical infrastructure needs to go beyond the traditional basic testing. The standard actually calls out optional test parameters that are recommended to also be run in these smart buildings. And the reason for that is when we think about, take digital lighting as an example, because digital lighting is going to require the highest wattage of what's called power over Ethernet, or PoE, to be run. That's part of a smart building. You're getting your power from the network. That's part of what makes it green. I'm not using regular electrical voltage. I'm taking advantage of the cable that's already there to both connect it to the network as well as get my power. Well, in some of those instances, if the infrastructure isn't tested properly with things like DC resistance, which measures the resistance on the cable from pair to pair or within pair, the cable actually could run the risk of overheating because of the power on the wire. It's still running data over it. But there has to be measurements in a deeper way made on these types of network infrastructures. And for some, this could mean longer test times. You think about the contractor who's going to deploy these environments, testing hundreds, if not thousands, of runs in a building. And for some test equipment that's out there, this could run up into the 22 to 24 second range per test. When you add all these extra tests in, what's very unique about the purpose-built solutions from AEM is that we can run all of the standard tests plus all of the optional tests in 6 seconds. That really makes a big difference when you think about you're testing hundreds, if not thousands, of runs. That time difference is a big deal. So basically, knowing what needs to be tested from that physical layer, even into power over Ethernet load testing and some other aspects.
So how is the enterprise cabling landscape changing and why?
Good question. So, all of these different devices that are being deployed, many of them are going to require power over Ethernet to get their electricity. And when we think about historically how different buildings are getting their network connectivity, getting their power, whether it be a traditional network enterprise or even in an industrial environment, which is also typically using something called field bus, which is not an Ethernet technology. But in these environments, they're now deploying, these building sensors that measure what is the temperature, what is the humidity, so that as those things are reported into the network automatically senses the environment and raises the air conditioning, lowers the window shades. That field bus technology is not compatible with all of these new devices being put onto the network. Another thing that needs to be taken into consideration is oftentimes, these things, whether it be a sensor, RFID reader, security badge scanner, those things, oftentimes they're deployed longer than the 100-meter limitation of your traditional infrastructure cabling, your 4-pair infrastructure cabling. So what is the solution to all of this? The solution is the introduction of something that is called single pair Ethernet, or SPE. And what SPE is it is very similar to 4-pair Ethernet. It is an Ethernet technology, which is good because Ethernet is ubiquitous. Everyone accepts Ethernet. But with single pair allows users to actually run that cable longer than the typical 100-meter distance limitation. They can actually run it up to 1,000 meters. So we think about the benefit of being able to deploy that cable to longer distances for those technologies that I mentioned. The other thing is that single pair Ethernet also allows for power to be deployed over it in the form of something called SPOE, or single pair power over Ethernet. Or there's another technology called POODLE, power over data line. In your traditional network infrastructure, you would be looking at using the SPOE type power. In automotive technologies, which is another place that field bus was used, but they're moving to SPE, that's where POODLE power is being deployed. So single pair Ethernet is up and coming technology. The IEEE standard defining this new testing methodologies and the deployment requirements is in writing now. AEM is very active on that standards committee, and we do today support single pair Ethernet testing with the draft standards. But single pair Ethernet is a big shift, if you will, as far as physical layer cabling infrastructure that will play a big role in smart building technologies.
How will cabling infrastructure planning need to change to adapt to the increased number of connected devices on these networks?
That kind of goes back a little bit to what I was referring to when we talked about the planning. I think their organizations are going to have to become more savvy with the different types of tests that will need to be run. So in addition to the testing of the physical cable itself, there is other testing that needs to be considered. I've mentioned power over Ethernet technology a couple of times now. Power over Ethernet is really a very impactful and very distributed technology in these smart buildings. And having the ability to measure not only a DC loop resistance measurement during the initial deployment, pre-deployment, if you will, of that infrastructure, just to be sure, do I have any resistance on this cable? As well as being able to measure actual power load once all of the network devices are deployed. The PSEs, which is your power source equipment, in essence, it is the switch providing power, as well as getting ready to deploy the PDs, or the power devices. These are those sensors and cameras and access points, those things that are going to require power. There needs to be a way to be able to test the actual power load at that jack. Really, users need to know, am I getting enough wattage at this jack to support this end device? A lot of cable reuse may be taking place as organizations are trying to go greener, take advantage of these technologies. And when we think about cable reuse, you have to be really careful in the measurements that need to be made and having a mindset of what has to be tested. So not only can the cable support, from a physical infrastructure certification perspective and the power that I just mentioned, but the other thing that has to be taken into consideration as part of a testing strategy is the ability to measure signal to noise ratio, SNR. So this is basically a measurement of hey, is my signal, my data signal that I rely on for communications within my network infrastructure, is that signal strong enough to get through noise on the wire? Noise is essentially traffic. It could also be power. In industrial environments, this is especially important. There could be electromagnetic interference. So our test equipment, being purpose-built for these environments, can actually push traffic onto the wire. It can actually ask the PSE to send a power load on the wire. All the while we make the measurement of signal to noise ratio at 2.5, 5, and 10 gigabit Ethernet, giving a user the assurance that these link speeds, that the devices they're going to be deploying that require those link speeds, a Wave 2 Wi-Fi access point would be a good example. It requires 2.5 and 5 gig. Can this network infrastructure of this existing cabling support the link speed and the traffic flows of what I'm now going to be imparting on it? That wasn't the plan when it was initially deployed, but can it support it now? We have seen real world cases where the cable is tested with, only the basic certification measurements and it passes with flying colors. But when you test that cable using the optional test parameters that I mentioned, as well as some of these PoE load and SNR measurements, the cable fails. And imagine if you had not done that testing and went ahead and just deployed the devices, the detriment to the end user is going to be a lot of wasted time because cameras may not turn on, sensors may not operate, access points may not function to their full potential. And it's because things weren't tested to smart building testing requirements.
Can you tell us more about the tools and infrastructure options that planners will need to enable scalability, adaptability, and to reuse existing cabling?
Yeah. So, again, I think it's really going to come down to, from a tool set perspective, something users really have to be mindful of is that, smart buildings have really taken hold in the market in the last few years. And test equipment that has kind of been out there, previously in years past, it was not designed with these kinds of needs and technologies in place. And what is unique about the AEM test solutions is that these products were purpose-built for these smart building environments. So when we think about not only the need to certify the copper, but also fiber optic. And in fiber optic, there are some devices that are deployed, say, out in a parking lot on top of a light fixture, a security camera that not only needs to connect to the network, but it needs power. It may be cost prohibitive to run power to that. So there's technology called hybrid powered fiber that actually runs a DC line of voltage along with fiber in that same sheath, if you will, of the fiber optic. And AEM test equipment has the ability to simultaneously certify that fiber optic as well as make a DC resistance measurement and voltage measurement of that electrical wire. And then we think about the signal to noise ratio capabilities that I just mentioned, being able to measure actual power load, being able to measure both 4-pair and single-pair Ethernet, all of this with a single piece of test equipment, because it can become very, not only cost prohibitive, but honestly, from an end user's perspective, difficult to manage if users have to purchase multiple pieces of test equipment in order to cover all of these needs, not only different user interfaces, but you think about training that is required for all these different pieces of test equipment, where having a purpose-built solution with multi-function capability, it's one piece of test equipment, one learning curve, easier for the teams to learn and adapt to. So I would say, really thinking about the methodologies of how they're going to test and look for technology that was purpose-built for these network environments and a broader breadth of testing function that's really needed today.
And can you give us an overview of your suite of products which help organizations with this exact challenge?
Sure, happy to do that. So we do have a couple of different products very specifically designed for these smart building environments. The first one that I'll mention is the Test Pro CV100 multifunction cable certifier. This is a modular-based platform that provides test function that includes everything that I have spoken about today, in addition to also having the ability to test, once that network gets deployed. It also provides the ability to test into the network infrastructure. Now that all the network components are deployed, from this jack location, is it configured properly? Am I on the right VLAN? What switch have I plugged into? What slot? What port? If there are any issues, providing troubleshooting capabilities, trace route, ping, things like that. And then from a Wi-Fi perspective, because every network infrastructure these days has Wi-Fi, and even being able to validate, all of these smart building devices are connected. From a Wi-Fi perspective, can I see all the access points and their SSIDs that I'm expecting to see? What is their signal strength? What channel are they on? So not only from an initial deployment and certification perspective for both that physical 4-pair and single pair, but even from a fiber optic perspective, being able to certify that fiber optic, as well as the signal to noise ratio, the PoE that I mentioned, and then being able to validate the network itself. That product is really aimed at folks like cable contractors, system integrators, those who are responsible for the deployment and certification in accordance with cable manufacturer warranty programs. That's really who that product is designed for. It provides a bidirectional certification in accordance with the standards. We have another product in our lineup called the Network Service Assistant. And it actually has many of the same capabilities, but this product is really designed for your network administrator, your frontline network technicians, and it too provides the signal to noise ratio testing that I mentioned, the power over Ethernet testing, the wired and wireless network connectivity testing. But where this product is very unique, and I really kind of refer to it as a hybrid tester, is that it bridges the gap between what is commonly referred to as a qualification tester and a certification tester. In certification, you must certify the cable to those industry standards that I talked about. And that's typically function that your cable contractors are going to have. But sometimes network owners who have those administrators and frontline technicians I mentioned, there are times when they're doing moves, adds, and changes, and they also need assurance that the cable meets a standard cable certification, such as Cat5e, Cat6, or Cat6a. And traditionally, they would either need to A, call a cable contractor to come on site, pay them for that, and test that cable, or B, they use a lower grade validator or qualifier, which really is just going to give them continuity of the cable, actually, or C, they have to buy a certifier. And a certifier for this user is something they're only going to use periodically, because really the majority of their day is going to be spent doing that network connectivity and Wi-Fi connectivity device deployment. So it really becomes a challenge. And it can become cost prohibitive for them to have to purchase multiple pieces of test equipment, which honestly, they typically can't afford. They've got budget for one piece of equipment. The network service assistant actually has a technology in it very unique to AEM called CertaLite. And CertaLite provides that ANSI TIA 1152A standards compliant test, but from a single end instead of bidirectional, which we're doing in our test pro. The standard calls out a single-ended methodology. And in doing so, AEM has created a small little far end adapter that goes on the other end that allows a category certification test, if you will, with a pass-fail result, but from one end. And what this does is it gives that network owner the ability to get assurance. Yes, this cable passes Cat 6A, in addition to all the typical things they do. And historically, they would need to either, like I said, call in somebody to do that test or purchase a separate piece of test equipment. So it really is a big time saver. And we're able to offer these solutions at price points that network owners, users of any size can afford, because not only does AEM design the test equipment in-house, we also have the ability to manufacture in-house. And this allows us to have a cost savings that we can pass on with very competitive pricing for users of all sizes to be able to afford these solutions, whether they're in the contractor system integrator space or the network owner space.
And finally, then, can you give us some best practice advice for organizations to enable them to adapt to these new requirements?
Good question. So, from a best practice, one of the things I'd highly recommend is that there is some great information out there, and I've seen more and more coming onto the market. I know I myself participate in the TIA, the Telecommunications Industry Association SPEC group, which is the Single Pair Ethernet Consortium. Also, the Ethernet Alliance. Also, we have a group that's very dedicated to these technologies. And in these consortiums, you're looking at participants of vendors that span all of your different cable manufacturers, connector manufacturers, some test equipment manufacturers, and we are all working together to build and create content and materials to help educate the market on what does a smart building mean? What are all of the technologies you should be aware of? How do you need to be thinking of testing these? So from a best practice, I would say one of the first things is knowledge. Understand how these networks are different. Smart building networks are not the networks of yesteryear. They are more impacted, which means as they think about the strategies that are going to be used to not only certify it, but ongoing management and troubleshooting in these environments, be educated about all of the different technologies you need to be prepared for from a testing perspective.
Brilliant. Thank you so much for your time. It's been great to chat to you today.
Sure. Thank you for having me. I really appreciate it.
Thank you.